first of all, a small recap about the moles, and we have discussed about the definition of the moles in the last class as well. That moles are basically, if you want to define the moles, so moles are basically defined as the atomic mass or the molecular mass or the formula mass, right? There are three types of mass. Atomic mass is for the atom which are present in the periodic table, right? Molecular mass is for the molecule. For example, if you make a molecule by combining two or more atoms, just like water, H2O, carbon dioxide, CO2. So the mass of that molecule is known as molecular mass, right? And we have discussed it various times that how to calculate the molecular mass. And then we have the formula mass. Formula mass is for the ionic compounds. The method for calculating both of molecular mass and formula mass are the same, but just is the difference of the word over there, right? Molecular mass is for the covalent compounds and formula mass is for the ionic compounds, right? Okay. So the atomic mass, molecular mass or formula mass of a substance expressed in grams, right? Expressed in grams is equal to 1 mole. Right, we have discussed about this definition in detail a lot. That, for example, if we talk about carbon, so carbon have a atomic mass, relative atomic mass of 12, right? And you all know that the atomic mass, either we have atomic mass or molecular mass or formula mass. All of three of these do not have any particular unit, right? For example, carbon's atomic mass is 12, but it's without any unit. It's just a number 12, right? Similarly, if I take any molecule, for example, water, H2O. So for water, we would be having Mr, molecular mass, relative molecular mass. And when you will be calculating its relative molecular mass, just like this, 1 multiplied by 2 plus 16 multiplied by 1, so you got 18. So it's 18 is also just a number, right? So molecular mass is also just a number, not a unit. And similarly applies for the formula mass as well, right? So for example, if you want to formulate the formula mass of NaCl, so NaCl, Na is equals to 23 multiplied by 1 plus Cl is 35.5 multiplied by 1. So it comes out to be 58.5. So it's also without any unit, it's just a number 58.5. So all the atomic mass, molecular mass or the formula mass are without any units, right? So what scientists did, they expressed these units in terms of in terms of grams, right? So what they did, they converted this 12 into 12 grams. Similarly, they expressed this 18 into 18 grams and this 58.5 into 58.5 grams, right? So when they express this atomic mass, molecular mass or the formula mass in grams, now this gram basically equals to the moles, right? This gram is equal to the moles. And what they are saying in the definition, that if the atomic mass is expressed in grams, then it is equal to 1 mole, right? And it is equal to 1 mole of a substance, right? So if I am saying that I have 12 grams of carbon, which is basically the atomic mass of carbon, right? So the atomic mass of carbon is 12. I express it in the grams, and now this 12 grams of carbon means that it is equal to 1 mole of carbon, right? Similarly, for water, you have 18, but when you express this in grams, it becomes 18 grams, and now 18 grams of water is equal to 1 mole of water. And similarly applies for the sodium chloride as well, right? That's 58.5 is equals to 1 mole of NaCl. So you can see for the 1 mole of each of the compound or the element, the number of grams are different. For example, if you want to make 1 mole of carbon, then you have 12 grams. But for 1 mole of water, it's 18 grams, right? So basically it depends upon the atomic mass or the molecular mass of the substance, right? So that was the first definition, right? It's just a small recap about it. So one more thing I would like to add, that for example, 1 mole of water is 18 grams, right? So if I ask you how much mass of water would be in the 2 moles of water, so obviously in 1 mole, if you have 18 grams, so in 2 moles it would be double, right? It would be around 36 grams, right? Similarly, if I ask you about the carbon's 1 mole is 12 grams. So if I ask you how many grams are there in 3 moles of carbon. So 1 mole is containing 12, so 3 moles containing 3 times. So 12 multiplied by 3 equals to 36 grams, right? So on. So that was the quick recap about the first definition of the moles, right? The first definition of the moles. Okay. So now there is one more definition related to the moles, right? As you can see, it's written over there. Okay, now we have to discuss the second definition. Now the second definition is basically related to the number of particles which are present over there, right? The number of particles. Okay, now the number of particles means that how much atoms, or you can say how much molecules are present in 1 mole of a substance. So for example, let us take one container, and let's suppose that in that container, if I say that I have 1 mole of sodium, let's suppose 1 mole of sodium, right? So if I ask you that what is the mass of 1 mole of sodium, mass, I am talking about the mass. So you all know that the 1 mole is basically equal to the atomic mass of the substance, which is expressed in grams. So if I am talking about the sodium, so you have to check the atomic mass of sodium. The atomic mass of sodium is 23. So basically the mass equals to 23 grams. So if you take 23 grams of sodium, that is equal to 1 mole of. Right? So that was just about the mass. Now if I say that if I have 1 mole of sodium which is equal to 23 grams, so obviously in that sodium you would be having a lot of atoms of sodium inside it, right? As you can see, these are the atoms, or you can say these are the particles of the sodium, right? So there would be millions and trillions of particles of the sodium inside it, right? The various atoms. Now you have to count those atoms, 1, 2, 3, you have to count them, right? That how many atoms are there in this 1 mole of sodium, or you can say 23 grams of sodium, right? So it's very difficult to count them. So there is a scientist whose name is Avogadro, right? So Avogadro has done this part for you, that he has calculated the number of particles in this 1 mole, and he says that if you have any substance which is equals to 1 mole, right? The Avogadro says that 1 mole of any substance, 1 mole of any substance contains 6 into 10 raised to power 23 particles, right? So according to Avogadro, if you have 1 mole of a substance, then no need to count the particles. The particles are 6 into 10 raised to power 23. So since I am having 1 mole of sodium, so the number of atoms of the sodium which are inside it would be equal to Avogadro's number, which is 6 into 10 raised to power 23 atoms, right? So that is basically equals to 1 mole. So I hope the second definition is also clear to each and every one of you, right? So if I take the another example in terms of molecule, if I say I have 1 mole of water, right? So 1 mole of water would be equals to, if I ask you how many grams, so obviously you would be calculating the MR of the water, and MR of water comes out to be 18, and you have to express in grams, so it becomes 18 grams. So 18 grams is equals to 1 mole of water, right? So in that 1 mole of water, since water is a molecule, so water would be having a lot of water molecules present over there, right? So a lot of water molecules would be present. So you have to count those water molecules which are over there, right? You have to count all these molecules. So since the quantity is 1 mole, so according to Avogadro, if you have 1 mole of any substance, either it is atom or either it is molecule, so the particles will remain same, that 6 into 10 raised to power 23 molecules. Now since the water is in the form of molecules, so I am writing 6 into 10 raised to power 23 molecules over there, right? Since sodium was in the form of atoms, so I was writing atoms over there, right? And similarly the last one, the particles are either in the form of atoms or molecules, or either they are in the form of ions as well, right? So for example, if I take 1 mole of sodium chloride NaCl, so if I ask you how much mass it would be there, so you have to calculate its molecular mass. So it comes out to be 58.5 and it's grams. So NaCl units, there would be obviously the NaCl units inside it, and how many NaCl units would be there? Obviously, according to the Avogadro's number, it would be 6 into 10 to the power 23 formula units of NaCl inside it, right? So that was all about the second definition, that in 1 mole you have this much particles, which is 6 into 10 to the power 23. So for example, if I have 2 moles of a substance, so how many particles would be there? Obviously the double of it. So you have to multiply this number, Avogadro's number, by 2. If I have 3 moles, so obviously you have to multiply this Avogadro number by 3, right? So in this way you can solve the various examples of it. So here you can see these are the 2 formulas which you have to follow, and you have to memorize these 2 formulas. The first formula is for calculating the number of moles. Right, it's very simple, mass in grams divided by AR or MR. Whatever the mass is given to you in the question, you have to divide that mass with the atomic mass or the molecular mass, so you can get the moles. So atomic mass, for example, they are asking you to calculate the moles of anything which is in the atomic form. So you have to check just AR from the periodic table and put it in the denominator. And for example, if they are asking you to calculate the moles of the molecule, then you have to calculate the MR by your own, and obviously for that also you have to check the data from the periodic table as well. And similarly, the second formula is for the number of particles, which we were discussing just right now, that 1 mole of substance contains this Avogadro's number of particles. So if you have 2 moles, so multiply it by 2. If you have 3 moles, so multiply by 3. If you have 4 moles, so multiply by 4. So the particles would be the multiple of Avogadro's number in it. So I hope this is clear to everyone. So you have to memorize these 2 formulas, and according to these 2 formulas, you will be solving the different past paper questions and the different numericals related to this topic. So moving on to the numericals now. Okay. Now this is the question, and in this question, you can see it's saying that how many moles are in the 40 grams of water, right? So as you can see, it's written how many moles are there. So basically, you have to calculate the number of moles. They are asking you to calculate the moles. And the further it's written that how many moles are there in 40 grams of water. So what is this 40 grams? If I ask you what is this 40 grams? So obviously gram is a unit of mass. So basically the thing is that the mass of water is given to you. And the mass of water is how much? It's 40 grams over there. And they are asking you to calculate the number of moles, right? So obviously we have just studied the 2 formulas, right? So obviously we would be applying the very first formula, which is for the moles. And what is the formula of moles? We have discussed it just right now, that is mass in grams divided by AR or MR, right? So mass in gram divided by AR or MR, right? So since in this particular numerical, you can see the example is of water. So what I would be doing, I would be calculating this for the water. I would be applying the formula with respect to the water. So therefore I am writing moles of water equals to mass in gram divided by, now in the formula there was AR and or MR. So right now since I have water over here, so obviously I would be writing MR in the denominator, not AR, right? Why MR? Because water is a molecule, so I have to take MR over there, right? Now you have to solve it. Okay. Now since you know that the mass in gram is already given in the question, which is 40 grams. Now this mass in gram is 40 grams. So put 40 over there in the numerator divided by mR. Now mR of the water you have to calculate it by your own, and how the mR can be calculated you have done a lot of time before as well. So you have to check the periodic table for it, and from the periodic table you can see the hydrogen is having the AR of 1. You have to check the ARs, and the oxygen is having the AR of 16. So in the denominator you can calculate the MR. For hydrogen it's 1. How many times hydrogen is there? 2 times. So 1 multiplied by 2 plus you have oxygen, you have 16 multiplied by 1 over there, right? So now solve it. 40 divided by 18. So you have to take out your calculators, and in the calculator if you divide 40 by 12, so you get the answer 3.33. So the answer you are getting is 3.33, right? So 3.33 moles, and obviously the unit would be the moles. So this is your final answer for this, right? So it's very simple questions. I hope it is clear to each and every one of you. Now let's move on to our next question. Now in the next question you can see it's written how many grams are there in 3.7 moles of Na2O. Now you have a compound Na2O, and they are asking you to calculate how many grams, right? So if I make out the data, so they are asking you to calculate the mass in grams, right? Mass in grams of what? Na2O. In the question I have given Na2O. So I have to calculate the mass in grams, and you can see in the question it's written how many grams are there in 3.7 moles. So if I ask you what data is given in the question, so obviously it's moles, it's written over there 3.7 moles, right? So moles of Na2O is already given to you, which is 3.7 moles, right? And you have to calculate the mass in grams. So if I ask you which formula we have to apply, the first one or the second one of the number of particles, so obviously you would be applying the first formula, because in the first formula there is moles, mass and grams and all that. So you have to apply the first formula here. So again you have to apply the formula of moles. So right now we have to apply this formula for Na2O, and the formula becomes mass in grams divided by since Na2O is a compound, so we would taking MR of Na2O. Now you have to substitute the values over there. Moles of Na2O are already given to you. You can see it's 3.7 given in the question. So moles of Na2O are 3.7, so I have substituted the value over there, equals to, now mass in grams. Now mass in gram is unknown to you. They are already asking in the question to calculate the mass in grams. So since it is unknown, and that is the value which I have also have to calculate it, divided by MR. Now MR is not given in the question. Obviously MR and ARs are always not given in the question. You have to calculate the MR by your own. You all know about it. So for the calculation of MR, you have to check the periodic table, and in the periodic table you can see that for sodium, right, for the sodium the AR is 23 when you look into the periodic table, and for the oxygen the AR is 16. So substitute the value in the formula Na2O. The formula is Na2O. So sodium is 23 multiplied by 2. 2 times sodium is there. Plus then you have oxygen, which is 16 multiplied by 1. Right? Now solve this. You would be getting 3.7 equals to mass in grams divided by Now 23 multiplied by 2 becomes 46, and 46 plus 16 becomes 62. Right, so in the denominator you are getting 62. Now in order to calculate the mass in grams, right, what you have to do, you have to cross multiply this. The 62 will go on to that side and it will cross multiply, and then you'll be getting your answer of mass in grams, and you would be getting 3.7 multiplied by 62. So solve it in a calculator. 3.7 multiplied by 62, and you are getting it 229.4. 229.4. Now since it's mass in grams, obviously the unit would be in grams, right? So 229.4 grams is your final answer for it. So I hope this question is also clear to each and every one of you. Now moving on to the next question. Okay, now in the next question it's saying that how many atoms are there in 14 moles of cadmium? Now in the question it's saying how many atoms, right? Now it's written how many atoms. Now how many atoms means they are asking you about the number of particles, right? They are asking you to calculate the particles, because you all know that the particles are in the form of atoms, molecules and formula units or the ions. We have just discussed it before as well. So number of particles and particles are in the form of atoms in this question. So basically you have to calculate the number of particles in this question, and the data which is given is 14 moles. So moles of cadmium are already given to you, and the moles are 14 moles, right? So now you have to apply the formula. So if I ask you which formula would we have to apply, the first one for the moles, which is mass upon ARMR, or the second one? So obviously since the second formula is for the number of particles, obviously you would be applying the second formula, which is for the number of particles, and you all know that the number of particles is calculated by the formula which is moles multiplied by Avogadro number, which is 6 into 10 to the power 23, right? So since the number of atoms we have to calculate or the number of particles we have to calculate, both are the same things, right? Moles are already given to you in the question. You can see in the data it's 14 moles over there. So put 14 into 6 into 10 to the power 23. So when you will solve it in the calculator, so you would be getting 14 multiplied by 6, you would be getting 84, or you would be getting the answer 84 multiplied by 10 to the power 23, or you can write it in this form as well. If you solve in the scientific calculators, you will be getting the answer in this form, which is just like this. So you have just put a decimal over there. So both are the correct answers. Either you write 84 into 10 to the power 23, or you can write 8.4 into 10 to the power 24. Right. So these are the number of particles, and obviously it would be having no unit, because it's just a quantity. You have to just count them, right? So it's just a single number over there. So I hope this question is also clear to each and every one of you. Okay, now moving on to the next type of question. Now in the next type of question is saying that how many moles, now you have to calculate the moles, right? Now calculate the moles. Now what is given in the question? In the question is giving H3PO4. So you have to calculate the moles of it. Are there in 4.3 into 10 to the power 22 molecules of H3PO4. Now if I ask you what is this data, which is 4.3 into 10 to the power 22 molecules of H3PO4. Now with this, the unit is written molecules. Just focus on the unit. It's not the moles, it's not the mass in grams, it's molecules. So whenever the word atom or a molecule is written in the question, it means that they are talking about the number of particles, right? I hope it's clear to everyone. Whenever they write down the unit molecules or atoms, it means that they are talking about the number of particles. Most of the time the student gets confused about that. Either these are the moles, or they say that these are the moles which are given in the question, or they say that this is the mass which is given in the question. If it is the mass, then it would be written G over there. If it is the moles, so it would be written moles over there. But right now it's written molecules. So molecule means number of particles are given to you, right? So I can make a data over there that number of particles are given to you, which is 4.3 into 10 to the power 22, and you have to calculate the moles. So if I ask you which formula do I have to apply for calculating the moles, if I apply the first formula, if you say, okay sir, in the first formula it's mass, moles equals to mass in grams divided by AR or MR. So can I apply this formula for calculating the moles? We are having the moles in this formula as well. But I cannot use this formula, right? I cannot use this formula. And why I cannot use this formula? Because in this formula you need mass in grams, and you have to divide that mass in gram with the AR or MR. So if I ask you, is the mass in gram given in the question? No, it's not given over there. So how could you use this formula? Because the mass in gram is not given to you, right? And you have to calculate the moles, it's not given, right? So obviously you have to apply the second formula, which is for the number of particles, right? So number of particles also have moles included in it. So number of particles equals to moles multiplied by Avogadro's number, right? Now the number of particles are already given to you, which is 4.3 into 10 to the power 22. So what are these? These are the number of particles which you have to put and substitute this value over there. So instead of this number of particles, you have to substitute the value, which is 4.3 into 10 to the power 22 equals to moles. Now moles are obviously unknown to you, and they are already asking you in the question to calculate the moles. So put moles over there, and in the formula then you have multiply by 6 into 10 to the power 23, right? Now since you have to calculate the moles, so you have to bring this number on the left hand side. You have to bring this complete number on the left hand side. So when you will bring it to the left hand side, so the formula would be becoming moles equals to 4.3 into 10 to the power 22, right? 4.3 into 10 to the power 22 divided by, this number is since multiply, so on the left hand side it would be dividing 6 into 10 to the power 23. So you have to divide 4.3 divided by 6, so you'll be getting 0.71. So you'll be getting 0.071. This is your answer for this. Okay, so final answer is 0.071 moles is the final answer, because since you have calculated the moles, so the answer, so in the unit you have to write the number of moles over there. Another question, and you have to solve this question as your homework task, and make sure that you complete this homework by before the next session, right? And if you have any queries related to today's session, so you may ask in the comment box, and as soon as I would get the time, I would be answering all your queries over there. So meet you in the next class. Up till then, take care and Allah Hafiz.